Many expensive chemical elements go into making smartphones such as this one. And lots of metals and rare earth elements are mined in Asia and Africa under inhumane working conditions. But there are efforts underway to try to gain these valuable substances using other means.
Exactly, Joy. Some scientists are working on plants that are able to pull these materials out of the ground and store them in their leaves. It's a brand new way of extracting metals. There'll be no need to rip up the ground, destroy land, and exploit workers. Let's take a look at how these new super plants would work.
This is reed canary grass. It might not look spectacular, but it has very useful features. Oliver Wiche from the Freiburg University of Mining and Technology wants to make use of them. The plant absorbs rare earth elements and germanium from the soil. These are precious metals that are used in a variety of high-tech products, including smartphones. 90 strains of reed canary grass are growing here on different kinds of soil. The aim is to see which strains under which conditions absorb the largest amount of valuable metals.
These are not nutrients that influence a plant's growth, but the plants mistake these elements for nutrients, such as silicon and calcium.
The process they want to optimize is called phytomining, and it could be used anywhere.
Germanium and rare earth elements are found in soils around the world, in roughly the same concentrations, whether it's European or African soils. And we can make these elements accessible with this extraction process.
The reed canary grass is harvested, then it's taken to the lab. The plants are fermented in a small facility. The grass demonstrates another useful feature. During the fermentation, the grass produces biogas, which can be used for electricity and heat generation. The material that remains after the fermentation process contains the desired metals. This process is also interesting for project partners in Kenya.
Phytomining could play a role in Africa because of this combination with biogas. We work with the Taita Taveta University in Voi. It's a mining university that has an agricultural component. So there, they could combine biogas production with mining.
And this is how it works. Biogas production is the first step in the process. The second step is metal extraction. In the lab, high temperatures, high pressure, and acids break down the fermentation remains into their essential elements. Researchers examine the extracted metals in a mass spectrometer.
We see concentrations of 2 milligrams per kilogram for germanium. And for all the rare earth metals, we find a combined sum of around 50 milligrams per kilogram.
Extracting metals from plants is not yet profitable, but if Oliver Wiche is successful, yields will increase. Mining with super plants could eventually solve many of today's resource and energy problems.